Hi, my name is Piotr Sapiezynski, and I'm an associate research scientist at Northeastern University. Today, I want to tell you about a project that I did with my collaborators at Northeastern and Upturn, and the paper is called Algorithms That Don't See Color. So if you open an American newspaper before 1964, you might see something like this in the classified ads section. Job ads were divided by gender of the expected candidate, and often also explicitly stated the race of people who should apply, with different opportunities for white and black people. One could argue that this was an effective way to broker jobs in a society where jobs were only done by people of specific demographics, with a reasoning along the lines of the job seekers can focus their attention on the jobs that they're actually eligible for, and the advertiser get their ad budgets optimized to reach the relevant people. Obviously, things have changed since then. Nowadays, we see this as clearly discriminatory, and it has been actually illegal for decades through the legislation like the Civil Rights Act and particularly Title VII on equality of opportunity. Advertising has also largely moved online, so the process of deciding which ads are relevant to whom has become much more complex. Any possible discrimination in this space is also much more difficult to observe right now, but it is not impossible. So today I want to tell you about our experience with detecting and quantifying such problems in modern ad systems. I will walk you through how advertising on Facebook works and how we can use the available tools to measure gender and age bias. Finally, I want to also talk about how our research led to achieving accountability through the legal system. So let's start by clarifying a confusing aspect of the online advertising flow. There are actually two phases to online advertising. The first phase is targeting. This is where the advertiser is in control, and they set the budget and describe their target audience. In practice, this advertiser's budget will rarely be large enough to reach every single person in the target audience. So the platform has to make choices about who among the targeted audience will actually see the ad. This is the second phase, the ad delivery. It's controlled by the platform, and it is optimized for profit. Both of these phases can lead to discriminatory outcomes. Let's start with the first phase, targeting. Julia Angwin and others at ProPublica had a series of articles showing that Facebook allowed for this old-fashioned discrimination in job and housing ads. Basically, Facebook allowed the advertiser to specify the gender or age of people that they wanted to show the ads to, and the advertisers could even use Facebook to exclude people based on what Facebook inferred as their ethnic affinity. The articles from Julia Angwin focus on the core audiences as the tool for discriminatory targeting. This is the tool that allows advertisers to target people by their characteristics, such as demographics, location, or interests. But this is not the only way in which advertisers may target and discriminate. More relevant to our study, there are two tools called custom audiences and lookalike audiences. Custom audiences allow advertisers to upload a list of personally identifiable information, for example, names, phone numbers, and email addresses, for Facebook to match with their existing users. So rather than describing the characteristics of their target audience, the advertisers provide a list of specific individuals to target. And finally, lookalike audiences is a tool through which Facebook will find users that are similar to or look alike those you uploaded through a custom audience. In previous work, actually, our group at Northeastern showed that lookalike audiences are actually quite literal. If you upload a list of men, it will find more men. If you upload a list of black people, it will find more black people. After these publications in ProPublica, Facebook was sued by a number of civil rights organizations and subsequently settled and agreed to make some changes ostensibly to mitigate these issues. The changes they agreed to had two aspects. First, Facebook removed demographic targeting and excluding from protected ad categories. Protected ad categories are housing, credit, and employment ads. Second, for these protected ads, Facebook was to modify their lookalike audience algorithm so that it wouldn't explicitly use age, gender, zip code, or membership in Facebook groups in deciding who is similar or looks alike. Now, that new algorithm is called special audiences, and it can use all other information on the users apart from these explicitly forbidden characteristics. Facebook actually left both of the versions of the algorithm running at the same time. Special audiences for opportunity ads and lookalike audiences for all other ads. We used this opportunity to ask a simple question. Does it actually work? Since both tools are running, we can feed the same input information to both of them and measure differences in the outputs. So the main question for the paper is, if you remove the sensitive attributes from the input of these algorithms that find lookalike audiences, do you end up with audiences that are not biased? To answer this question, we became advertisers on Facebook and started building target audiences with baked-in biases that we know. Say, for example, we want to measure the gender bias. We start by creating a list that contains personally identifiable information of a few thousand women of different ages and races. We take this information from publicly available voter records from North Carolina, where every voter self-reports their gender, age, and race. We upload this list to Facebook through the custom audience. Facebook then identifies its users who match the PII we uploaded based on the data that Facebook has already collected about their users. We then ask Facebook to find other Facebook users who are similar to those identified people. We specifically ask them to do it in two ways. The first way is through a lookalike audience, which uses all of the information Facebook has from their users, including the demographics. They use it to find similar users. The second way is through a special audience, which was created in response to the settlement and uses all the information Facebook has apart from the explicitly listed demographic attributes. Now that we have two audiences, we run two copies of the same ad at the same time with the same budget. One is targeting the lookalike audience, the other is targeting the special audience. So let's take a look at the results. We actually use tools that Facebook provides to every advertiser to measure the demographics of the user who saw our ads. In the plot that you see here, the x-axis shows the gender distribution in the list of individuals that we uploaded to Facebook. And the y-axis is the gender distribution of the people that Facebook deems similar to our source audience. So for example, when we uploaded the list that only had women, the resulting lookalike audience consisted of nearly exclusively women. Conversely, when our list had only men, it resulted in a lookalike audience that consisted nearly exclusively of men. Now, as we varied the gender ratios, we saw that the gender bias of the lookalike audience is nearly linearly correlated with the source audience, and it falls basically on the y equals x line. But this is something that we already expected based on previous work. Now, one could hope that if we now remove demographic attributes from the input of these algorithms, the resulting special audience would have less gender bias, and then it would look something like this. So if it was perfectly unbiased, then regardless of the fraction of men in the input audience, we would have an output special ad audience that is gender balanced. So let's take a look at what actually happens with special ad audiences. We see very strong biases, and the results still mostly fall on the y equals x line. When we do statistical testing, we actually see that the differences between lookalike and special ad audience are, some of them are statistically significant, but the effect size is very small. So we can still say that even if special ad audience do something to alleviate the problem, they do not entirely eliminate the bias in the resulting audiences. We observe similar trends when looking at age skew, where the older the audience, the input audience, the older the audience of rich users, both lookalike and special ad audiences. We also observe potential biases with respect to race and political views, but the method for these measurements is a bit too complex for the 15-minute talk. So please read more in the paper. Of course, the gender and age experiments had audiences that were basically biased specifically for the purpose of our measurements. But let's now take a look at a more realistic example. Imagine you're an employer and you want to advertise openings at your company. You know that you mostly have youngish men working for you, and you want to overcome this bias, but you still want to find people who are similar to your current employees. What you can do is to upload the PII of your current employees to Facebook as a custom audience, and then have Facebook create a special ad audience from that. And to simulate the simulation from a perspective of an employer, we had to find a good example of a real company with a vastly biased workforce. So we chose Facebook. How do we get personal information of Facebook employees to upload as a custom audience? Well, we created a list of all possible 3, 4, and 5 character strings. We appended @fb.com to each, And we uploaded that list of 12 million addresses as our custom audience to Facebook. As I mentioned, the next step is that Facebook matches this to their existing users, and they actually matched 12,000 of these addresses to actual Facebook employees and their email addresses. So then we asked Facebook to find people who are similar to those employees and to show our job ads to them. We also have to have a baseline for comparison. So we uploaded a random sample of American phone numbers, and we created a special audience from that. So in this plot, on the x-axis is the fraction of the total audience, and the y-axis lists the different age groups. So you can also see we split the results by gender. What you can see here is that when we use the special ad audience generated from random phone numbers, not Facebook employees, we see a pretty even gender distribution, and the delivery is mostly to very young people below the age of 24. However, when we use the special ad audience generated from the list of Facebook employees, we see that the resulting audience is 88% men, and these men are predominantly in the 18 to 44-year-old range. So what we're observing here is that the special ad audience replicates demographic biases, known demographic biases of the Facebook workforce. So the effects that we're talking about in this paper are not just an artifact of the fact that we first created crafted the custom audiences with known biases, but these effects can also occur in realistic scenarios. So far, we've seen that removing sensitive attributes from the input of the special ad audience algorithm does not necessarily help overcome the existing biases. We saw that the problem persists both in purposefully biased and in realistic audiences. So now let's take a step back and imagine that the special ad audience miraculously work and produce samples that are perfectly balanced by age and gender, effectively eliminating bias in targeting phase. Would that solve the problem of discriminatory advertising in the delivery phase? To answer this question, we created a special ad audience from 1 million US phone numbers to have a good random sample of the population of Facebook users, and also to push the algorithm to create a special audience that would also be a fair representation of the user base. Now we run 3 different job ads at the same time with the same budget and targeting the same audience. The only thing that's different between these ads is the content of the ad. Our generic job ad delivered to an audience that's mostly young and more or less gender balanced. This is our baseline. The job ad for AI engineering delivered to an audience that's skewed more towards young men than the reference. And finally, the job for supermarket cashiers delivered predominantly to middle-aged women. So even though we've used a very inclusive audience, we run 3 ads at the same budget at the same time targeting the same inclusive audience, Facebook still heavily skewed the delivery of these ads. This experiment shows that if a special ad audience algorithm actually produced unbiased audiences, the delivery algorithm would still introduce heavy demographic skews based on the content of the ad. So when we talk about the fairness of particular algorithms, we have to remember that these algorithms don't operate in a vacuum, and instead they're a part of a larger socio-technical system. So the fairness of the final outcome is not guaranteed by making sure that any one of the algorithms in the pipeline is fair. There are a few things that I hope you take away from this talk. We showed that fairness through unawareness or colorblindness might help a little bit, but it does not necessarily solve the underlying problem. More specifically, removing demographics from the input of the algorithm doesn't mean that the output will necessarily be fair. Further, when talking about an algorithm fairness, we have to think about the context that these algorithms operate in. Fixing problems in one aspect of the project does not guarantee that the results of the whole system will be fair. It is also important to mention that the results that we presented in this paper actually led to real-world accountability. Our findings were a basis of the first ever case where the Department of Justice challenged algorithmic discrimination under the Fair Housing Act. As a result, Facebook will have to stop using special ad audiences altogether, as they don't guarantee the outcomes that they were designed for. They also will have to fix the biases in the delivery of housing ads, and they will have to pay the maximum penalty available under the Fair Housing Act. So the third takeaway here is that there is a growing recognition of the danger of algorithmic harms, and real-world accountability can actually be achieved. Finally, I would like to thank Ava Kaufman and Ariana Toplin from ProPublica and Joss Fong from Boss for their coverage of our work. The way that they presented our results really helped us talk about the work in a more accessible way. And I also want to thank my co-authors at Northeastern and Upturn, Levi, Avijit, and Aaron. Thank you very much for tuning in. Please find more details in the